Guys, let's try this problem right here. Here we have a lens combination of two converging lenses, and the focal length of the first converging lens is given by 30 centimeter, and the focal length of the second converging lens is given by 20 centimeter, and we have an object at 50 centimeter from the first converging lens. And the question here is asking us to find out the first image distance caused by this first lens, and then second image distance caused by this second lens, and let's see how we can find it. Now first of all, let's go ahead and draw our ray tracing diagram. And we know that for a converging lens, the first ray we draw is we draw that one parallel to the normal line, so it's going to go like this straight line, and then after it hit the lens, it's going to refract toward the focal point of the other side of the lens, so it's going to go like this, go through this one, and that's going to be the first ray. And let's look at the second ray. Second ray, we are going to go through this focal point, so it's going to go like this, right? After it hit the lens, it's going to refract and go parallel to this lens, actually parallel to this normal line, so it's going to go like this, right? So I had to actually draw this lens a little bit bigger in order to illustrate this one clearly. Now let's go ahead and draw this one a little bit bigger. So the lens is going to be like this, right? A little bit bigger, and let's also draw this one a little bit bigger. Okay, so this is going to be our first image distance. This is our first image, and this is our first image. Let's call this one S1 prime. Okay, now to find the first image distance, we can use this formula, that is S prime is equal to SF over S minus F. Let's go ahead and calculate that one. And this is going to be S prime is equal to SF over S minus F. And we know the object distance is 50 centimeters, so this is going to be 50 times the focal length of the first one is 30 centimeter, so 30 divided by 50 minus 30, and 50 times 30 is going to be 1500 divided by 50 minus 30, that is 20, and that's going to give us 75. Since we are getting positive 75, this means this is a real image. That makes sense because we are getting the image behind the lens, so this is a real image. This is real image. And let's look at the magnification to find out whether it is inverted. We know from the diagram, we know that this is inverted, but let's make sure with this one. M is equal to negative S prime over S, and S prime is image distance, that is 75 centimeter, and negative 75 over S is object distance, that is 50. So this is going to be 3 over 2, that's going to be negative 1.5. So this is our image size of the image, like magnification. So this is going to be 1.5 times bigger than the original image, right? So this is our first image. Now to find the second image, you can think like this, like when this one hit this, when this ray hit this lens, what's going to happen is it's going to converge like this, little bit right inside, and we are going to have an image wherever these two meets. So let's assume this is here, but we are not sure. This is just an assumption, right? We can calculate it through that, calculate it through our calculations. So this is S2 prime, and now the object for the S2, like for the second lens, this is going to be the object. This is going to be the object for the second lens, and we know that we found out this is 75 centimeter from this lens. Okay, from here to here, this this is 75 centimeter, and I had to actually give the distance between these two lenses. So let's say this is 10 centimeter. Okay, so if this is 10 centimeter, then the distance from the second lens to the image is going to be 65 centimeter, because the total is 75 and the distance between these two is 10 centimeters, so this is going to be 65 centimeter. So the object distance for the second lens is going to be 65 centimeter. So we can say S2 is equal to 65 centimeter, right? And also this is behind the lens, right? Actually since we are having this one behind the lens, okay, this is object, and for this one object is this direction, and for the first one we had from the front side, that's why we had positive, and since this is behind the lens we are going to have negative right here. So this is going to be S2 is going to be negative 65 centimeter, negative 65 centimeter. Now we have the object distance. We are trying to find image distance. Now we have all the information available because we know the focal length of the second lens, that is 20 centimeter. So we can go ahead and apply in this equation to find out the S2 prime. Let's call this one S1 prime. S2 prime is going to be the image distance of the second lens, actually second image. So second image is going to be S2 times F2. Let's write this one S1 F1 S1 F1. So this is going to be S2 times F2, S2 minus F2, and S2 we know that is negative 65 centimeter times F2 is 20 centimeter. We know that one from here, 20, and in the denominator we are going to have minus 65 minus 20, and that's going to give us 65 times 20, that's going to be 1300, negative 1300, over negative 65 negative 20, that's going to be negative 85, and if you divide these two together, that's going to give you 15.3 centimeter. Now this image is real, right? That makes sense because this is behind the lens, right? So this one also real image. Now let's look at the magnification. So this is M1, this is M2. Magnification is going to be minus S2 prime over S, and S2 and S2 prime we found out that is 15.3 centimeter, and also we have minus sign in front. 15.3 over S2, that is negative 65, and that's gonna give us 0.235, and here we are getting positive answer. But if you look at the diagram, we have the inverted image. The reason for this one is because the image for this one, image of the first lens was the object for the second lens, right? So the image of the first lens was inverted. So when we do this calculation, we since the rest related to this one, this is positive, so it means this is also inverted, right? So this is also inverted. And now to find the total magnification, this is magnification related to this one. So the new image is going to be 0.235 times smaller than the big image, right? Now to find the image size related to the object, we had to use this equation. M total is equal to M1 times M2. So if we multiply these two together, that's going to give us the magnification related to the object. Now M1 we calculated, that is negative 1.5, and M2 we calculated, that is 0.235, and if you multiply these two together, you should get negative 0.35. So this makes sense. This is inverted related to the object, and also it's 0.35 size of the object, so it means this time smaller, like smaller by this size, right? And that's how we do this kind of problems. I hope this helps. Thanks for watching.